So welcome to this little short work example revision tutorial looking at how you calculate speed from a distance time graph, because I know from some of the conversations and emails I've had with some of you over the last week, so a little bit of clarification is needed and a little bit of struggle for some of you. So I just wanted to make sure that we got a concrete example of what it looks like so that it's a useful reference point for you. Now, we've got an example distance time graph drawn out here with a question at the top that says, what was the object's speed at 2? So we're going to look in a minute at what was the speed of the object that this distance time graph is recording over this section of its movement. Okay, so we're going to look at that in a little bit. And just for the sake of each distance in this graph measured in meters, time measured in seconds. Now, before we do that, we're just going to think typically how we would describe the object's speed overall. Now, the object's speed overall would be from, what was its average speed from the start, where it was doing nothing and it wasn't moving, through to the end where it finished moving over a set period of time. Now, that's relatively simple to do, because if we take our final point on the graph, and let's say that we imagine that that is 10 meters, okay? And we say that this is approximately 10 seconds, we can work out average speed for the total distance of the journey that the object took over this period of time by going, right, this is our very end point. So our distance equals 10 meters. Our time equals 10 seconds. So overall, the average speed of the object for the entire journey, the entire length of time that it took and the entire distance that they traveled would be the final distance, 10, divided by that final time, 10, would be 1 meter per second. Now, a little bit more complicated when it comes to working out the speed of an object during a section of the journey. Now, the way in which we do this works on a very similar measure, but we need to find our start point and our end point of this section of the journey. So, if we were to draw it on our graph, we would rule off like so, and we would rule off like so. And we'd go, okay, what's the distance and what's the time at each of these points? So we might say this is approximately 7 meters. And this is approximately, making a very rough guess, 6 seconds. Whereas here, you might say that this is 2 meters, and this is 1 second. So we want to work out what speed was over this time frame. So the simple way in which we do that is just work out our differences. Okay, so if we end up for our distance 7 minus 2. So we know that they've gone 5 meters because started at 2 meters, went up to 5 meters. Okay, so the distance is 5 meters. Now, time-wise, to go from 2 meters to 7 meters, it was between 1 and 6 seconds. So time, again, what would our difference be between the two? 6 minus 1 equals 5 meters. So if we want to work out the speed over this time, we then just simply divide, not 5 meters, 5 seconds, sorry. We divide our two values. So speed equals 5 meters divided by 5 seconds could equal 1 meter per second. Okay, So that's how we do it. Now, obviously, as we've said, if a line is shallower, that's not a problem, because we'd expect it to be slower at that point. Whereas if part of the line is steeper, we'd expect it to be faster. And again, we can look at that, look at what's the speed at 1. So we've got our speed at 1 meters per second along that distance of the journey. Whereas 1, we know that our start point is 0 and 0, and our end point is 2 and 1. And we could, well, no, let's ignore that bit for now. We don't need to complicate this. But in general, that's how you go about working out the speed of an object at a set place on a distance time graph.